If you need to set up AWS Virtual Private Cloud, you could make it happen, the AWS Management Console and Automating IT. In a DevOps, building AWS services tools like Terraform Remote State is a more scalable and automated approach to cloud resource provisioning. Sharing data with root model outputs is convenient. Although Terraform Remote State only exposes output values, its user must have access to the entire state snapshot, which often includes some sensitive information. I published data for external consumption to a separate location instead of accessing it remote state. This lets you apply different access controls for shared information and state snapshots. To share data explicitly between configuration, I used pairs of managed resource types and data sources in various providers, including system Amazon S3 published with AWS S3 bucket object resource type read with AWS S3 bucket object data source. An AWS VPC is a single network that allows you to launch AWS services within a single isolated network. Technically, an AWS VPC is almost the same as owning a data center, but with the built-in additional benefits of scalability, fault tolerance, unlimited storage. AWS virtual private clouds are restricted by region. You cannot have one VPC spanning across regions with up to 5 VPCs supported per region. A key advantage of using a separate explicit configuration store instead of Terraform Remote State is that the data can potentially also be read by systems other than Terraform, such as configuration management of scheduler systems within your computer instances. For that reasons, I selected a configuration store that you other infrastructure could potentially make use. The Terraform configuration next creates a VPC, creates an internet gateway and attaches it to the VPC to allow traffic within the VPC to be reachable by the outside world, creates a public and private subnet, creates a route table for the public and private subnets and associated the table with both subnets, creates a NAT gateway to enable private subnets to reach out to the internet without needing an externally route table IP address assigned to each resource. You should see the VPC created with the same ID Terraform returned earlier. Terraform created more than just the VPC resource, but all of the resources required for the VPC subnet, route table, internet gateway. Now the engineer can create servers. When we run the main TF file, we get our output IP address server security group, so the project is connected. Amazon VPC lets you provision a logically isolated section of the Amazon Web Services cloud where you can launch AWS resources and a virtual network that you define. You have complete control over your virtual networking environment, including selection of your own IP address, ranges, creation of subnets, and configuration of route table and network gateways. You can also create a hardware virtual private network, connection between your corporate data center and your VPC and leverage the AWS cloud as an extension of your corporate data center. You can easily customize the network configuration for your Amazon VPC. For example, you can create a public-facing subnet for your web servers that have access to the internet and place your backend systems such as databases or application servers in a private facing subnet with no internet access. You can leverage multiple layers of security, including security groups and network access control list, to help control access to Amazon EC2 instances in each subnet. Amazon VPC enables you to build a virtual network in the AWS cloud. No VPNs, hardware, or physical data centers required. You can define your own network space and control how your network and the Amazon EC2 resources inside your network are exposed to the internet. You can also leverage the enhanced security options in Amazon VPC to provide more granular access to and terraform the Amazon EC2 instances in your virtual network.